Okay, let's dive right in. We live on this massive planet, right? But everything we've ever seen, everything we've ever touched, is really just its thinnest outer layer. You know, the mountains, the oceans, whole continents, it's all just the skin. So what in the world is going on thousands of kilometers right under our feet?
I mean, that's one of the biggest questions in geology. It's like a classic detective story where the crime scene is literally the entire planet's interior. We can't send a camera down there. We definitely can't visit. So, how did we crack the case?
The distance to the Earth's center is, well, it's over 6,000 kilometers. That's an almost unimaginable depth.
And yet, the deepest hole humanity has ever managed to drill is just 12 kilometers deep. 12! That's not even scratching the surface. It's less than 0.2% of the way there. So again, how did we figure out what lies beneath? Well, like any good investigation, it all starts with piecing together every single clue you can find, beginning with the most obvious ones. So geologists kind of split their evidence into two main piles. You've got your direct clues, that's the stuff we can physically hold and analyze, and then you've got your indirect clues, which, well, they require a little more clever thinking to figure out. Direct clues are things like rocks we pull out of super deep mines or magma that blasts out of volcanoes. But the thing is, they only really tell us about the shallow parts of the inside. To get a hint about what's happening way, way down, we need those indirect clues, stuff like the makeup of meteors, which are basically leftover planetary building blocks, and even tiny little changes in gravity around the globe that hint at how lumpy the mass is deep inside. But you know, all these early clues, they weren't quite enough. It was all a bit circumstantial. To really see inside the Earth, scientists needed a game-changing tool. They needed a way to listen to the planet itself.
And that tool, it comes from earthquakes. When an earthquake shakes the ground, it releases this incredible amount of energy. That energy creates powerful seismic waves, we call them body waves, that travel right through the entire planet. It's basically like giving the Earth a giant ultrasound.
Now here's where it gets really interesting. There are two main types of these body waves. First, you've got P waves, or primary waves. They're the fast ones, and they can plow through pretty much anything, solids, liquids, and gases. But the second type, the S waves, or secondary waves, they're different.
And this right here, this is the golden ticket. This is the one fact that unlocks the entire mystery. S waves absolutely cannot travel through liquid. Period. You gotta remember that. So that brings us to the smoking gun of our whole investigation, a bizarre phenomenon that gives us undeniable proof of what the Earth's hidden structure really looks like.
Scientists started noticing something really weird. After a big earthquake, the instruments that detect these waves, seismographs, in certain parts of the world would just go completely silent. The waves simply weren't showing up. This area of silence got a name, the shadow zone. It's this region where seismic waves get blocked or bent as they travel through the Earth, creating this blind spot on the other side of the world. And here is the big reveal. The P waves have a pretty small shadow zone, but the shadow zone for S waves, it's enormous. It covers a staggering 40% of the entire planet's surface. Once you get a certain distance from an earthquake, poof, they just vanish. So think about it. We know S waves can't travel through liquid. We see them disappearing across this huge chunk of the globe. There's really only one possible explanation. They must be hitting a massive liquid layer deep inside the planet, and that liquid layer is the Earth's outer core.
And just like that, with that final piece of evidence, the case was cracked. By tracking the paths of countless seismic waves from thousands of earthquakes, scientists could finally confidently map the hidden layers of our world.
So what does that map look like? Well, the structure they found is made up of 4 totally distinct layers, and we'll start with the one right here, beneath our feet. We live on the crust. It's the Earth's outermost solid part, and it's incredibly thin, relatively speaking, kind of like the shell of an egg. It's only about 5 kilometers thick under the oceans, but it can get up to 70 kilometers thick under huge mountain ranges.
Beneath the crust is the mantle, this huge layer of rock that makes up most of the Earth's total volume. Now, it's technically solid, but it's so hot that over millions of years, it flows super slowly, kind of like thick molasses. And finally, we get to the center of it all, the core. As you'd expect, it's made of really heavy stuff, almost entirely iron and nickel.
And it's split into two parts. You've got the liquid outer core that we found with those missing S waves. But inside that is a solid inner core. Now, you might be thinking, wait, if it's hottest at the very center, why is it solid? And the answer is just one word: pressure. The pressure down there is so unbelievably intense that it literally squeezes the atoms together, forcing them to be solid even though the heat is extreme.
So, okay, we've mapped the planet's interior. We solved the puzzle. Awesome. But why does any of this matter? Why should we care about these super deep, remote layers? It matters because what happens down there drives everything we experience up here on the surface. That slow flow of the mantle, that moves the tectonic plates, building mountains and causing earthquakes. The heat escaping the core, that's what fuels volcanoes. And the churning of the liquid outer core, that generates the Earth's magnetic field, which protects us all from harmful solar radiation. It's literally the engine that makes our planet a dynamic, living world. This whole thing is just an incredible story of scientific detective work. It shows how with a little bit of clever thinking and just listening really carefully, we can actually map a world we can never, ever visit. It's a huge testament to human ingenuity, and it just makes you wonder, what other deep secrets is our planet still waiting to tell us?